Hi, I'm Tom and I talk about code. Today we're back. We're doing part 2 of working out how to use the color lookup table on the PlayStation 2. This is going to allow us to draw indexed color, so to have textures that are much more compressed, to use color palettes, so potentially to reuse a texture several times, but have a different palette for each draw, so it looks a bit different. I'm trying to get the Pico 8 color palette up and running just as a good standard 16-bit color palette. Our two options for color palette sizes are either 16 colors or 256 colors, with nothing in between. And let's have a quick look. I made a few... hold on, if I actually get into the right folder there, that was confusing. I made a few small tweaks since the last stream. It now does something different. It still doesn't work, but it does something different. I like that this kind of looks like a face or something in here. Horrific, like if you wanted a creepy glitch noise texture, this is what I would go for, right? But not what we want when we're just trying to draw. Let me double check what we're actually trying to draw here. If I go into my CLUT test, CLUT test, it's a really cumbersome word, but we'll get around it. Salty Doubts, hi, how you going? Working hard, or hardly working. So we're building a 4-bit color index texture, right? So basically we have 8 4-bit digits, which are represented by a 1, and yeah, we fit 8 of those into a single 32-bit word. And we're just filling the whole texture with the same thing right now. If we multiply this by anything, so if we multiply this by, say, 3, we should get 0x3333333333. If we multiply it by 10, we should get 0xAAAAAAAA. Similarly, this was the kind of thinking here. Now, I did get a couple of different behaviors, just changing this value a bit, I think. So this has this extra black bar here, and I think when I set it to 2 or 3, yeah, see, 2 gives me a color. Now, here's the thing. If I go over to the GIMP, is this color in our palette? This looks mighty similar to this color, but I don't think it's the same color. Or is this like... They're mighty similar, aren't they? That is almost too similar to be coincidental, because I think if we try and draw color 3, again, we get something that is mighty similar to this color. Salty Doubts will have me on mute, because yeah, he is working. Perfect. Let me pop out chat so I can bring people up. Signet Sido, hello, welcome. Also, shoutouts to Killmaster417 who followed me not too long after my last stream finished. I'm getting lots of follows between streams at the moment, so I'm not going to be calling out all of the followers, which is a really awesome problem to have, right? Too many followers. How will I ever manage? But yeah, just one today, so I'll call him out. But yeah, welcome. Thank you for stopping by. So, we can draw these 2 colors seemingly from the palette. Okay, that's good. But now if I come in and I go to 4, we hit garbage land, and it's just a black bar. But yeah, then interestingly, if I go to like 10, we seem to hit transparent garbage land, and we just get like nothing there at all. So I've got some interesting thoughts about this. Let's go back to color 2, right? So we've got this bluey color up here, and then garbage. So what this could mean, this could mean a few different things, okay? There are a couple of options. To hone in on these options a little bit more, almost seemingly at random, I'm going to try and halve the vertical height and see what this does to the resulting texture. Okay, and so this looks like what we actually had before just got stretched out, right? If we go back to 1, and so I guess that's at like 1/5 of the way down the texture, right? If we go to 0.2, yeah, we get this whole block color. So what's interesting about this, right? This tells me that it is likely the resolution of index to color that's going wrong, right? I'm quite confident that this part is working and this part is not, right? So our texture is one color, right? It's all just these, just index 2 into our palette, which should actually be this one, 0, 1, 2. This should be index 0 anyway. But once we get beyond this index, things break, and things break in a very unintuitive way. So it's really hard to know at this point if we're uploading the palette correctly. Oh, there was one more thing from last stream that's important to call out. If we look at the palette, right, you can kind of see, so this is target header stuff. You get into pixel data, I think here, I think here, right? This is, the first color's black. Is this black? Yeah, so this is pure black, and then this is what? 1D, 2B, 5, 3. If we look at this, 1D, 2B, 5, 3, FF. So red, green, red, blue, green, alpha. Wait, are these bits reversed? Okay, I've got to think about this, but the alpha goes... We have an alpha. The texture I was loading yesterday was only a 24-bit texture. It didn't have this alpha component, so they were packed in differently, and someone did suggest that in the chat, and they were right for the wrong reason, I think. But, okay, so we're actually using a 32-bit color texture now, which is good. Also, just to be completely certain that nothing's going wrong here, because the documents are quite clear, the color format of your palette has to be the same as the color format of your frame buffer. Previously I had this set to PSM 24, now I've got it set to PSM 32. It shouldn't make a difference. The Z buffer still uses whatever format, that doesn't matter, but just in case this is a problem, we're gonna stick it like that. So one way I want to check, because there was one other thing that's actually probably important to call out that I changed. Sorry, let me... Whoop. So if I go into Draw 2D, where is this line? It's in Upload Texture? No, it's in GIF. It's in GIF because when we set bit buff, a width of less than something. What's the width less than? Whatever. Basically, we were having 0 width, and so I changed this to 1 width. If I comment this line out, we'll see we get a very different behavior from drawing the texture, right? So if I run this is what we had last stream. Oh, and that's actually the same. Huh. Okay, well that's interesting. That I thought would make a difference. Maybe I like doubled up on this somewhere. Width divided by... Yeah, because the floor of... width divided by 64. That really should be should be 0 for this texture. Anyway, so that's weird. Maybe I didn't save or something. Nope. Okay, that's fine. Doesn't really matter. Actually doesn't matter. Not that important. But I'm going to keep it there because for what we're doing now, I think it's going to matter. At some point it might matter. So what I want to try, because I'm not 100% confident, if anything should show you my lack of confidence, that should do it. I'm not 100% confident about how small textures are handled. So I want to come in here and I want to make this a 256 color texture, right? And so to do that, I think we're going to need, so yeah, so it's 16 by 16. I should know that off the top of my head, but I do, because it's 2 to the 4 times 2 to the 4. So this is actually going to have exactly the same problem. It's not wide enough to do anything. Okay. This is going to be fine. I'm going to stop second guessing myself for 5 seconds. We're going to create an entirely blue texture. Okay, and this is going to be our color palette. So every index into the palette is going to be the color blue. We're going to export this. No, hold on. First, we're going to turn it into a 32-bit texture. That's important. Then we're going to export it as bigpal.tga. Sure. We're not going to run length compress it, and we're going to export with the origin in the top left corner. So we get a bright blue texture. Okay. So 16 by 16, we're going to go bigpal.tga. Cool. And so what happens if I just run this off the bat? What do we get? We get an empty. Is there something wrong that I'm doing? Pal gets uploaded. Pal gets set. So if I go to Draw 2D, I guess, and I go to set CLUT, it comes from here. So CLUT.textptr. Okay, so the width of the okay. So if I come in and I do what we did here, if I look at the actual bits in this file, right? Oh, hold on, I didn't make assets. That's why. Okay, so now when we run, we should see something, and we do, and we see a big blue square. Again, this is telling me, right? This is telling me that something is going wrong with the actual upload of a small texture. So what if I go absolutely crazy right now? What if I take this, I copy and paste it into the top left corner of this texture. Will I be able to select these textures with other crap in there? Export to big. I hope this works. I hope this doesn't like. I hope this uses same defaults. Replace, run length, top left. Okay, so if I run you now, we get this blue again. What if I take the first index of this text? Okay. Now we're no. I need to make assets. That's important. Now what do we see? Now we see something else. Okay, now we're getting some results, right? We're not getting the results we want to see. What if I grab like color 7? What if I grab color 16? What if I grab, like, let's say color 15, the biggest color in the palette, right? Okay, so something really weird's going on here. Something really weird is going on here. So it looks like maybe even the top left color is the one that's being grabbed this whole time. So what if I make this color red, for example, right? What if I make this color red? So I come down to a nice 1 pixel brush, I put a nice red pixel there, we export it to Big Pal, we replace it, we run length, encode from the top left, we make sure the right window is selected, and we grab a red pixel. Okay, now we're getting somewhere, right? Whatever we set this value to, it's always grabbing the top left. Does that mean we're not loading this still doesn't mean much, right? Or does it? Could we still be saying accidentally that the width of this texture is 1? But why do we get this weird corruption when it's a small texture, right? So could this possibly be working? Oh. Am I setting the wrong? And I'm definitely setting the right constant for the texture mode, right? Definitely. So what else could be going wrong here? The fact that we get a different result with a bigger texture means that the problem is in uploading the palette and setting the palette, okay? That is certain. That much is certain. And also just to, so whatever I set this to, I'm going to get this top left pixel. Whatever I set this to. Okay. I might have to refer back to the hardware manuals, but I feel like there's something else that I can do just based on what I know right now that I am missing. Okay. And if I look at it hard enough, I will see it. Sorry, I'm just getting a message. I have to keep my eye on my phone because I'm making a gigantic pot of chicken soup. And that will occasionally require my love. The apartment smells amazing right now. It just smells like really yummy chicken soup. I think I'm making noodles to go with my soup. If anyone in chat has a good noodle recipe, hit me up with it. Because every time I've made noodles in the past, it's gone horribly wrong. But partly that's because I never have enough patience to roll them thin enough, and I never have a sharp enough knife to get a really good, cut. Oh man. My adventures in cooking noodles in lockdown last year. Bad every time. Okay. So here's another thing that I'm going to try. I'm going to try making a PSM8 texture, right? And I'm just going to see what happens. I'm going to see if I can get something different because this should be a little bit different. It just should be. And it doesn't seem to do anything different, but that's okay. If I look at the actual bit pattern, we should see something is a little bit changed in here. When we set 16, so this high bit is now set when we set text 2. Okay, I do need the hardware manuals up. Perfect. Right where I left it. Text A, text 2. Perfect. Okay, and so we had PSM T4, which was 010100. Yep. 010011. Okay. So what's this top bit? COD. It's not the top bit that's set, is it? This top. No, it's the second to top bit. So we're in this mode. Load is performed. Let's try setting this to 1 instead. That might be a good place to start. So we go into where we draw a sprite. We set text to... I hard-coded this, didn't I? GIF. And that does... Where is it? 16? That does work. That does work, and that does draw nothing. So why would this draw nothing? CBP is going to CBP 0. So we have to update the base pointer, right? We have to. Otherwise it doesn't work. That makes sense. That makes sense. CPSM. CT32, that's fine. So we're reading the color information correctly, right? The problem must be the problem must be the width and height of the texture that we upload. But then why are there... So, okay, here's another thought, right? If I come back to here, what if I set this to a really high value, right? What if I set this to... Are we still going to get red? We still get red. So the 256 color palettes are working way better. Okay, they're working way better. Oh man, I need a way to turn off my smart texture uploads and just upload them directly in the buffer, because then I can see what's going on. Because I'm not confident that this number is working correctly now. So the other thing, I guess, from the Lua point of view is to math.floor it. And I guess the other thing I can do as well is for 162. Okay, so what if I say this isn't a PSM8? What if I say this is a PSM32, for example? Okay, and then we get some actual stuff in the buffer. What if I go like 02? Okay, so we can actually... So this looks like it's actually building the right thing, right? That's good. If we go to PSM4, yeah, we get crap. I was worried this would happen. I was worried I would get into this and not have any real direction. I was hoping inspiration would find me here. Okay. Where's Refraction when I need him? Where's Refraction PCSX2? Where's my boy? Okay, what are these other fields, right? CSA. CSA CLUT entry offset equals offset divided by 16. CSA equals 0 must be set. CSA. You know what? Just for a laugh, I'm going to set the storage mode to 2. I'm going to do it. I want to set bit 55 to 1. Let's go GIF. Let's go plus 0x. What is it? Bit 55. So let's work this out real quick. So it's C bit 55. Okay, so from the left, right? So 64, 60, 56. So 1, 2, 3, 4, 5, 6, 7, 8. So in the top word, right? So this is 63, I guess. Does this label at 63 or 64? This labels at 60. So 63. Then this is 59. Then this is 55, right? So 1, 2, 3, 4, 1, 3, 2, 61, 60, 59, 58, 56, 55. Yeah, so it's the top bit of this. So this needs to be 1. So in other words, that just is 1. So it's, what is it? 0, 0, 1, 0, 0, 0, 0, 0. And I can actually merge these together, but I won't because it's a little bit clearer, I guess. 1, 2, 3, 4, yep. Okay, that looks like it did something. If we look for where we set this text to, that is now set. Doesn't appear to change anything, which is odd, right? Because you would think it would. You would think changing the storage mode would change something, unless we've... That should be... this should be fine. Yeah, because there's no... Like, these don't touch the same 4-bit, like... What's it called? A nibble? Okay, so what if I come back to CLUT, and I'm doing quite a lot, aren't I? Okay, let's follow this through then. Let's follow through what happens to the texture. So we load texture. Right, we grab the TGA. The format is PSM32, sure, perfect. We get the data. Then we call VR texture. So VRAM, we get a texture from our VRAM slice, right? VRAM slice texture. The size equals this. That isn't true, but sure. We make an allocation for it. This is great because this means we're using way too much memory and VRAM for this, but this is just a test, so it doesn't matter. But we should probably put a marker on this, right? Should probably say, this function, right? We stopped using this for some reason, so we'll come back to that. But yeah, that doesn't need a comment because that's already there. And then we upload texture. So this must be where something happens, right? Upload texture. What happens? What happens in upload texture? Something about the width and the height that is different, okay? So TRX reg and bitbutbuff is where this width comes into play. First off, right? This should be 0 for some reason. For some reason this doesn't seem to make a difference, but with 0 versus with 1 this is important. And is it so that we just can't deal with textures that are not a multiple of 64, right? Is that just the case? Do I have to make this even bigger to get the behavior that we want? That actually, I'm just going to buzz this question over to the PS2 scene Discord. I guess this is a general question. I'm not sure. Okay, cool. I suspect I might actually just need to do a bigger texture, and maybe I can just save myself a lot of hassle right now just by making a bigger texture and testing with that. So let's go 64 by 64. Let's copy and paste this into here. We'll put it in the top left corner. And let's see what happens if I export this to my friend bigpal.tga. Replace RLE top left. That isn't right. So if we look at this now, right? If I go bigpal.tga, let me get that through less. We're gonna see 0, 0. Yeah, so this is the red pixel, right? And then this is the second B1, D1, B2, 1D, 2B, 5, 3, right? So these are 24-bit color pixels, we need them to be 32-bit. Not for any like particular technical reason, just because we haven't handled that logic in our loader yet. So let's re-export this. Cool. And now if I rerun this, we're gonna see more FFs, because the alpha is always FF, which is fully opaque. Perfect. So now if I make assets, now if I go into our loader, turn this into a 64 by 64, run it. Okay, well, that does something different again. I think that's partly because we're, oh no. So here is our 64 by 64. Oh, well, we're not setting the whole thing for one thing. So let's go. No, hold on. That's not right either. 64, 1, build vortex. Four pixels per thing. Wait, this is the maths I struggled with yesterday, so it should be 4, right? Okay. That's okay, because now what if I change this to a 1? Do I see a different color? I do, but I don't see the different color I expected to see. What if I change this to a 2? Do I see a different color? Okay, what if I change this to a 6? Do I see a different color? I do. So there are different colors in here, right? That kind of looks like one of these colors. What if I change it to a 7? Again, that's reminiscent of this color, I guess. But I don't know why these would be adjacent. Oh dear. What about A? What about my boy A? So this kind of looks like this color, I guess. Right? That's not. There we go. That is neither this color nor this color. That is not in our palette. But if I set this high enough, will I also see... So if I go to like FO, will it just be blue? No, it'll be white. Now white's definitely not in our palette. And then we hit the same issue with just like corruption. But I'm guessing... Is this maybe drawing from just like garbage memory? Is that why we're seeing such weird values? Rather than so it's like uniform block and then garbage? That would make sense. That would make sense. Ah, cool. Sorry, I got really distracted from chat there. Why the TGA format? TGA is notoriously simple to parse. So if you look at my TGA parser, it is this, right? Even this is just like post-processing, which I need to split out into a separate function. I do, you know, like it's 20 to 30 lines of code. BigPal.tga, yeah, he's my big friend, Big Pal. How do you memorize function pointer cool syntax in C? You don't. You just Google it every single time. That has been my approach for the last 6 to 7 years. It has never failed me. Except you'll never memorize it, and don't be afraid to look it up. I swear I've said that exactly that before on the stream. That's my advice to everyone. It's one of my favorite pieces of advice in programming. Okay. So I suspect we're not building this texture properly. I think that's a safe thing to suspect. So let's swap back to PSM4. Let's get back to what we're doing. Run this. Oh, this is going to get out of bounds again, right? Yeah. Cool. Awesome. Developers never remember things. We Google it every time. This is true. This is a true fact about developers. As a developer, a 9 out of 10 developers recommend. See, this is this is so different again. Because so many of these colors just do not appear to be colors. This looks like a pure blue a little bit, maybe? Or maybe it's this darker color. Because then you have this gray. And then you have these pinks. I see 2 shades of pink, right? There's a lighter pink and then this red. So if I change this back to pure black, is this pure black? I think this is the color palette, right? This is what it's meant to be. So let's go Sorry, let's, what's the P? P? N, that's the one. Let's export here. Yeah, so this is black instead. So this is actually reading from the palette. That's good news. That's good news. So maybe this texture just is being built weirdly, right? Because our buffer is the right size. Our buffer is the right size. It must be, because we have 64 pixels across. But no, we have 16. Wait. Have I done something weird here? So 128, right? This is how many things we're writing. We're doing 64 times 2, 128 times 8. Each one of these has 8 values in it, right? 8 indexed color pixels. Okay. So we're only filling a quarter of an image. Huh. That maths doesn't work out. My maths is wrong. How did I get to this now? Okay, let's do this again. I did this last stream. I'm going to do it again because I'm losing my mind. Okay, so we have a 64 by 64 texture, right? Each pixel in this texture, 7, 8, 9, ... right? Each pixel in this texture, each 8 pixels comes from one word. So 4096 divided by 8, so the number of pixels divided by the number of pixels per word, we need 512 words. So we need this to be 4 instead of 2. But then we overflow our buffer because 4 times 64 times 4, that's too many things. That's too many things. But these are 512 words. Why do I get... Man, I hate maths. I hate maths. Just kidding, I love maths. I just hate when maths hates me. Okay, I'm gonna have to take a quick break to check on my soup and to maybe do some napkin maths about this so that when I return, it will all just work. Should have done this off camera, but I didn't realize this was the problem. But this is looking very, very promising. I think this stream we're gonna get color lookup table working, at least for 4-bit color, maybe for 8-bit as well. Fingers crossed. Back in a second. Okay. Okay. We're back. We're back and we've worked it out. We've cracked it. I think. Maybe. Maybe not. Let's find out. Okay, so each word contains 8 pixels, right? So each row needs to be 8 words. Times 8 equals 64 pixels, right? But then we still need to be 64 high. So it's 64 by 8. That is the number of words that we're going to put into this texture. So we've underestimated, okay? So 64 times 8. We haven't underestimated. 64 times 8 is 512. So why then? Oh, that's 512 words though, which is actually 512 times 4. So that's actually 2048 bytes. That explains it. That explains it. This is where it's gone wrong. So if I go into VRAM, I go into texture. No, I go into wherever I calculate the buffer size here, right? I use VRAM size for this. And so this is why I'm not, in fact, using VRAM size, right? Where do I make it? Buffer. Oh, new texture, that's right. Draw 2D. New texture. Yeah, so I use VRAM size, right? So let's go VRAM size. Okay. Okay. So the size for a 32-bit or a 24-bit per pixel image is the width times height. So that's the number of pixels. You multiply that by 4 because you need 1 word per pixel. 3 or 4 bytes per pixel, but I don't think you don't pack them densely, right? 24 bits per pixel on the PS2 has an 8-bit window at the top, which you can fill with other random data. So then if you have a 16-bit texture, you should multiply it by 2, right? So I've halved it here, but really this means that you have per pixel, so 16 bits per pixel means that you have 2 bytes per pixel. So this is multiplied by 2. PSM 8, okay? So PSM 8, I drew these pictures yesterday, I'm going to redraw them. In PSM 8, you have an index, you have an index, you have an index, and you have an index. This is one. So this is in, I'm calculating this in terms of number of ints, number of words, whereas actually, like this calculation was counting the number of words, but actually it should be counting the number of bytes. It should be counting the number of bytes. So this is now times 0.5. So now if I run this, it will work. It will magically work. First time, where are we? And we get one whole color. Perfect. Okay, so let's try some different stuff. Let's try 1. Because we're doing 4-bit color, that doesn't quite work. Need to fill in the gaps. Okay, so 1. Let's have a look at our palette. Oh, that looks like a color on our palette. What if I go to 2? Okay, let's try something else. Let's say, let's let it equal J. So let's get a stripy texture. Nice. Okay, so this is starting to work, right? We can see, even though the colors are a little bit off. So 1, 0, 1, 2, 3. Oh, maybe my red, green, and blue are rotated around, right? Maybe these aren't being read in the correct order. Let's see. I got a new... how does a Lua to C integration work? It's pretty simple. There are good docs on it. I recommend the official Lua docs. Everything is communicated over a stack, which makes it just super easy. Just try building something. That is my advice. And if you have questions, come and ask in the chat in my Discord. We have a Q&A channel. I highly recommend people come and ask about it. Slowest, welcome. This looks confusing. Is this Lua? Yeah. So we're building draw buffers for the PlayStation 2 in Lua. So if we're drawing at the moment, right, every frame this is getting kicked off, this, you know, buffer has a bunch of stuff in it. Once you've done this for a while, you start to see the shape of these buffers. So this is all just setting a bunch of registers in the graphic synthesizer, to getting it ready to clear the screen. This is a bunch of geometry data which clears the screen. This kind of, you know, switches that off, and then we start drawing our geometry. This line here is really important in our draw buffer, right? Because we're setting up a color palette to draw from. And when we draw from it, we get something that's starting to resemble a color palette, but the colors don't quite line up. So that's the new hit list, or the new target on the hit list, right? But this is cool. This is starting to take shape. It's starting to take shape. But yeah, we're using Lua for this because it's very easy to prototype new things. So in my wonderful Draw 2D function, right, if we go down to where we're actually drawing a sprite, yeah, we mush all this stuff together in Lua, but it's a very quick and easy to iterate on it. But then I also have a C port of this Lua logic, which actually gives me performance and allows me to draw more than, you know, 10 sprites to the screen in a single frame. Which is kind of important if you're building a game. What happens to the Lua code? Is it transpiled to C? No, the Lua code is just interpreted by the Lua interpreter. You work at Google. Damn. Lua is like the easiest language to learn because it comes with no batteries, right? Everything that you build in Lua, you know, you just bind in C functions to actually do the work, and then Lua just kind of manipulates the Lua world, right? There's no standard library, or there is, but, you know, the standard library is like super lightweight and doesn't really do anything. That's also not quite true, but, you know, it's a great language to insert into another project and do crazy stuff like this. Yeah, okay, so we're interpreting Lua inside the PS2 emulator. Yes, so the PS2 emulator is a form of interpreter, and inside that interpreter we are running another interpreter, and then we could build a virtual machine inside a Lua and run that as well. The layers of indirection never end. It never ends. But yeah, no, one of the cool things about having, you know, not just an interpreter but a whole Lua runtime is the potential to hot reload scripts. So one of my goals long term is to have my PlayStation 2 talk to the network or listen, you know, on a socket or something, and I'll be able to upload scripts, or, you know, I even potentially replace some of the logic mid-frame and try different stuff out. So, you know, in my long-term dream, I will be running a program, I'll be able to pause execution, I will be able to swap from the C renderer to the Lua renderer, I will be able to dynamically change the way the Lua renderer works, change the way these buffers are being built, test some stuff out, hopefully without crashing the console. Usually I imagine that would crash the console, but just the potential to iterate that little bit faster in such a usually slow environment, it would be really cool. That's something I'm thinking about long term. But in practice may not actually be feasible. Alright, so it's time to look at our target loader. And this is the important bit, right? Because we swap these bits around. So what are we saying here? We're saying that from the temporary buffer, we take bit 3 goes to 3, 0 goes to 2, 1 goes to 1, 2 goes to 0. So if we have a color in a target, let's go, here's our TGA, here's our TGA, okay, and this is gonna be, right, our target is, and we looked at this before, our target is RGB, so BGRA, I think, right? So it's BGRA. The bytes go in this order. And then if we have this function, this is saying that 3 goes to 3. Okay, so A goes to A. So down here we have RGBA, right? So this function says 3 goes to 3, which is what we expect. 0 goes to 2, so this goes to this. 1 goes to 1, and 2 goes to 0. So we're doing this swap. And we could do this swap in place, and we should do this swap in place and get away with away from this temporary buffer. It was causing me issues 2 streams ago. It's not a great thing. Once I get it working, I can implement it in C exactly, and that's what I have already done for Draw 2D. Draw2D is fully implemented in C with everything up to this CLUT stuff. So I've actually got it working in a small game example that I've been playing with. Not on stream. I've been focusing more on the techie details on stream for now. But yeah, the idea is, yeah, prototype in Lua, and then as Lua is too slow to be practical, replace things with C. Alright, so I've hit another limitation of my understanding of how this works, because there's this awesome page in the hardware manual, okay? So something isn't right. Okay, here we go. Pixel storage format conversions. When transferring this texture data as this data, as PS... We're not doing this, are we? We're not transferring this data as PSMCT32. We're just transferring it as PSMT4 or PSMT8 or PS. So I think this doesn't... Yeah, this doesn't impact us right now. But we can, in theory, pack a bunch of textures together and then say it's a big transfer. Whatever, that's fine. One column, 32 by 4 to... Okay. Okay, yeah, so this is cool, but this isn't what we're doing right now. You can hear the birds. Yeah, I don't know what the... Is that a noisy miner? There are a bunch of really cool birds around this area. I've even heard kookaburras from here, which is awesome. You don't normally see them close to a city. Alright, block configuration in a page. So this sounds more like what we're looking at, right? Page, block, and column. Block allocation of page, pixel arrangement order in a column, right? Surely this is what we're dealing with here. Block configuration in a page. Column configuration in a block. I'm a bit confused about this terminology, okay? So maybe I need to go back further. Memory unit access. The GS local memory can be linear address space, yep. Cannot be accessed uniformly due to its complex configuration. Cannot be accessed uniformly. Okay, so a page is 8 kilobytes. And frame buffers and Z buffers can be page boundaries, that's fine. Access to a page does not result in a page break. Okay. Block boundaries. So I think, yeah, so 256 bytes. Synapsido, which document is this? This is one of the PlayStation 2 system hardware manuals. These are not something that should be distributed. Don't ask where I found mine. Extremely useful though. Extremely useful. Like literally the book on how to program a PlayStation 2. Okay, so a block is 256 bytes. Yep. Yep, so these are the things when you divide by 64. Column. It's documentation, okay? We're gonna gloss over the details. There's literally nothing else that will get me where I need to go building this stuff, so we're skirting the law, okay? I'm a bad boy. I play it fast and dangerous when it comes to pirating official documents for 20-year-old consoles. I would actually really love a physical copy of these, though. That would be amazing. I'm sure they exist somewhere. That would be a much better reference, right? I learn a lot better from a physical book, and I could like draw on it and stuff. Okay, so a column of 64 bytes can be accessed in a single cycle. Data to be read from and written to a column in the frame buffer and Z buffer in a single cycle. 204 8-bit. So does this mean that it can do 4 at the same time? Page, block, and column as following. Local memory is 512 pages. 1 page is 32 blocks. 1 block is 4 columns. Each page of block, each of page, block, and column corresponds to a pixel arranged in the form of a rectangle with 2-dimensional space in the buffer. The width and height of the rectangle. Ooh, yeah. Okay. 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 So how does this... So if we're uploading... Okay, this is starting to make more sense. If we're uploading either of these things... If this could focus the right window, please. I don't know, this window always gets focused when I shift back to this view for some reason. When I am allocating this, okay, VR texture, if either of these textures are not allocated on the boundary of a page, right, then we're going to have problems. Also, just by necessity, this is going to leak over a page. Both of our textures? Both of our... No, this is PSM T4, 128 by 28. No, okay, so this is small enough to fit inside one page, but a palette is bigger than a single page. So maybe if that alignment isn't in line with a page boundary, then we'll have a problem, right? Maybe, but surely, this is interesting though. Okay, so the address gets divided by 64, right? So if we have, let's say 0x A000 divided by 64, right? 64 is 2 to the 6. So this would be equal to 0. 0x A000 1, 2, 3, 4, 5 divided by 64. This would be A, right? Because this is 2 to the... Well, this isn't 2 to the... This is... Let's change this to a 1. That's easier to do with. This would be 2 to... Oh wait, no, hold on. Whoa. Sorry, I'm counting these as single numbers instead of doubling up. Hold on. Whoa. 6 bits. 1 0 1 0 0 0 0 0 0 0 0. If we divide this by 64, we just cut these off, right? So you get 1 0 1 0 0 0, which is equal to 2 8. Okay. So we need the end. We need the last 6 bits of our address to be 00. So in other words, if it's something like A001, then this won't work. If it's something like A0, what's another example? A0A0, this won't work because this has a bit in the lower half, right? Like we need the bottom 2 bits to be 0. So it can only be what is it? 8 C. What's the other? There are only 4 options. So what we need to do is log when we VRAM allocate what address we actually get. And I think we already do this. We do this. Okay, good. But we don't print it out as a hex digit, which is okay. We can do that conversion manually. If we come up here, we look at where we allocate it. The palette goes here in memory. So if we go hex of this 700. Now this is okay. This gives us, we can divide this by 64. So D2700 divided by 64. This is, it's hard to anticipate what the exact value will be. Hex. Cool. 349C. And so if we actually go through the draw buffer, we expect to see this 349C in this first buffer somewhere. 349C. Actually, we expect to see it whenever we... Wait, that's the palette, wasn't it? So yeah, we expect to see it 349 9C. Okay, we don't quite see it. The palette. It's the VRAM address of the palette. Let's open up our notes from last stream and just double check. Not stream archive, sorry. Which one had this? I think it was this one, right? Oh, this has all changed from then, sadly. Yeah, okay, this calculation changed because I moved stuff around. I'm almost certain though, right? I'm almost certain that it's a miscalculation. Okay, so let's run this again, right? We're gonna come in, we're gonna grab this again. We're gonna decode this yet again. We did it last time, we're gonna do it again. Let's go text, ISEVCOM, everyone's favorite dev font, or it should be, fantastic dev font. Not the one I use, of course. We'll merge this down. So, 1, 2, 3, 4, 5, 6, 7, 8. So this part of the buffer, this part of the register value we don't care about. This part we do, because if we go into our system docs, we can find, I think it's on like 151-ish. Where are we? Text 2. So we care about this part of the buffer. We care about bits 37 to 50. 37 to 50. So let's go 32, 33, 34, 35, 36, 37. So if we write this out in full, 10 0011 1001 0110 0001, and then these top byte we don't care about, right? 50, what is it, 56 to 64? Yeah, the top byte we don't care about. We don't care about less than this, right? So 32, 33, 34, 35. Wait. Oh yeah, sorry. 32, 33, 34, 35, right? Right? CBP 37. 32, 33, 34, 35, 36, 37. Yeah, okay. What am I doing? I was right the first time. So 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Don't need this. So this is our CBP. This comes out, if we regroup these bits to actually make sense, this is going to give us 0111, this, and then the 01 at the top. This is 1A, 4, E, 1A, 4E. So what's 1A, 4E times 64? 430,976. 698. Okay, so 403,976. Let's see if this showed up in our log at the start. 403. Either I decoded that wrong, or we're building our base pointer wrong. And actually, we log it again, don't we? Because I suspected this would cause problems. 13. Have I decoded wrong? Oh no, sorry, is this 861952, 861952, 86195. Okay, so this is consistent with what it gets set to here. So we're logging, when we log what we're setting the base pointer to, this is pre-divided, which is why we also log the undivided version. Okay, this is good. Now, so the hex of that number, of this number, that's excellent. Hex 13468,349C. So what if I... Oh, hold on. Anakin Loop, you're heading off. Awesome. Thank you so much for stopping by. Good questions as always. Hopefully catch you next time. This looks dangerously close to 349C, okay? Because if we just... Well, actually, let's leave this here, right? Let's imagine a slightly different grouping of these numbers. 3, 4, 9... And if this is a 0, then this gives us 349C. So either we've calculated this wrong, or we're bit shifting one bit too far. So let's assume that we're bit shifting wrong. Okay, let's assume we're bit shifting wrong. Let's shift one viewer bit over and run this again. And we get black. Probably a good indication that we were correct before. Okay. What if I go one bit further? Then we get black again. Okay, that was worth tracking. That was worth checking. Hold on, there was something else as well. Didn't I do something else? Didn't I do this? What if I get rid of that? Oh, I was in the wrong mode. This is promising. Is this the palette? Is this it? Have I done it? Do we have indexed color confirmed? I think we do. Okay, so the problem was the texture upload. Hilariously, now I can also change this to... Let's just for a laugh change this. Oh, that won't quite work, will it? It will, but it won't. Let's change it to a PSN8 texture. And then we get this strip. Yeah, cool. Because these are all way out of range. Nice. Okay, well, let's undo that. PSM4. So we can now draw sprites with indices. So what's a good... See, now the problem's going to be loading these sprites, right? What are the good options? Well, let's draw one, right? Let's draw an index sprite and see what options we get. So let's go 16 by 16, indexed, transparent. Let's go for a white background, square pixels. Cool. Let's load up a Pico 8 palette. Let's load up a Pico 8 palette. There it is. And let's go. Okay, where are we? Grid. Can we? How do we ungrid? So. So if I draw something with a couple of different colors in it. So then if I save this, what do I save it as? Let's go, yep, asset is fine. But what are my options? Because Targa supports indexed TGA. Targa does support this, doesn't it? TGA format spec. TGA does support this, I'm pretty sure. Number of characters and identification. Color map type. Yeah, okay. So we could save these as images with color maps, but then just like ignore the color map, right? And then we could even like post-process them to remove the color map. Okay, let's save this, right? Let's save this as a... But how do we... Because this is how I saved the targets before. Let's see what our options are. Let's do what I did before. I guess maybe I just need to make my own format. Maybe I need to write my own Targa parser or my own Targa processor. Because I do have this cool pipeline section, right? So, for example, I load object files for 3D stuff. I have the script conv.py that then converts them into a format that's basically ready to go just straight into the PS2 GPU. So I do this processing ahead of time so then I don't have to have an object parser in my C code base because they're awkward to do in C. So maybe I do the same thing here, right? And I just convert everything I can to use pallets, or I have some things that get converted to use pallets. Okay, that's an interesting thought. I think this is something to think about and maybe something to build off camera because it's going to be fiddly, but let's just remind ourselves here that we actually have this palette working. That is so exciting. That is so exciting. And it was a really silly, easy thing to fix as well. So now we know we have to load textures 64 by 64, can't do them any smaller. That has been semi-confirmed, I think. Okay, I've got a few thoughts about what this could be. I'm going to play around with some alignment stuff a little bit more, but yeah, it works. That's cool. That's good news. Let me just like turn off this noisy logging because it's annoying me. But this, I'll polish up, I'll port it to C, and we'll get this in the code base. Hold on. Draw 2D. Awesome. So, as always, thanks everyone who has stopped by, and thanks to everyone who has been tuning in. Where is this print coming from? I've got a rogue print. Where's this coming from? Something can't do that. It's in GIF. There we go. That's a little bit nicer. Sorry, I just had to do that for my own sake. Thanks everyone for stopping by, as always. Thanks everyone who's watching on YouTube. There are a lot of you, and it really makes me very happy. It's so good seeing people tuning in to the stuff I've created, seeing those views tick up. If you want to support the show, I now have, actually, while I'm messing around with this outro, look at this. I now have a donate button. You can head out and give me money. That's going to help me do things like fix up a couple of issues with my setup. You may notice my webcam is strobing a little bit. I've got some thoughts on how to fix that. I also need a few bits and bobs for high definition PS2 capture. Again, you know, if you obviously know, no obligation, but if people want to give me money to help support the show and help me level up the show, that would be wonderful. I've also recently hit 500 followers. I promised a little while ago that I would do a stream entirely in Comic Sans when I hit 500 followers. Maybe I'm crazy, but I am going to do that, and I'm going to build something really fun. I just need to work out a few of the details before I finalize it. Carpasaur, thank you very much for stopping by. Thank you very much for the feedback. And again, as always, check out my Discord. I think I've linked that down below. If I haven't, I will do that shortly. And before I forget, let's find someone to raid, because we've got a few viewers.